you got an extra 10 there, so let's go through it.
Then we want to know what
So what are the design flows for B, inlet B, and C? What'd you get for inlet B? What's your design flow? 5.6. You know, that is something about,
Okay.
okay, Nick
So
just
I
said, I
don't
said, what's
worry
the
about this
flow?
yet.
He said 5.56. You're going to, what, the hundredths?
Yeah.
Really?
So my
Hundredths? How accurate in flow is a hundredth?
You never know when you'll need it for something, so I don't.
Yeah. More significant number, and even then, when I'm doing larger flows, I might go to the nearest 100. I might go to the nearest 10. You know, this is not rocket science. And did you see the method and all the assumptions in the rational method? Don't go to the 100. Okay, so anyway, inlet B was 5.6, and what was C?
1.4.
Yeah, that's right. You have to turn it on. Yes. Everybody get that?
Yeah.
Great. Question 2. What's the time of concentration and design flow for pipe BC? What's the time of concentration? 25 minutes. And what's the design flow for pipe BC? People are getting 7. Well, there I am.
Yeah.
Whoa. Somebody else did that. 7.9 for the flow. Any questions about how we got that? Okay. Question 3. What's the sum of the design flows for inlets A and B? You just add them together. 4.9. Oh, well, you might have had 4.5 because it should be probably 10.1 because we were assuming we had the wrong for inlet A. Remember when we were going through it?
Yeah.
We had the wrong intensity. You had so I came up with 4.9. It should have been 4.5 according to you. Okay. So it's probably 10.1 in the way you're looking at it. So is this larger than the design flow for pipe BC, that 10.1?
Yeah.
So that's why we don't add design flows together. Because even if this were 10.1, you'd be saying you have over 2 CFS more if you added them up. And that means you might have to increase the size of your pipe to handle it. You don't want to do that. You want to keep this efficient and economical. Okay? So there you go. So they're saying 24% reduction. It's probably around 20%. Yeah. Why don't we use this design for pipe BC conservatively? That would be the answer. What's the answer?
Yeah, of course.
Right, it's too conservative. You don't need to do that. Because, and why is that? Right, and what's going to happen in area A? Will that flow come before or after the flow, the peak flow from area B? After, right. Because area A has a time concentration of 25 minutes, so it won't peak until 25 minutes. Area B has a time of concentration of 10 minutes. The peak will have already gone through, so you do not add them together. You don't want to add the peaks because they're coming at different times. Okay? Make sense? You're looking at it like, huh?
But I feel like it's possible.
No, it's not. If you did it correctly, it's not possible.
Well, I mean, say area, I guess it depends on how big area B is.
You've already taken that into consideration in the time concentration. So the combined flows will be attenuated. Because of the shorter time of concentration, the flow through inlet B will peak before the flow through inlet A, or basically when inlet A's flow comes through. And not, the ratio, the rational, not the ratio, the rational method accounts for this attenuation. Using the simple formula, sum of the two values would result in an over-design. Okay? And number 4, what's the time of concentration for pipe CO? 26, and what's the design flow?
8 point,
Eight,
well,
nine,
9.0.
Yeah, it would be
9.0.
9.0, so anyway, 8.96. But really, when you're doing design, round it up. I'd just say 9. I mean, really, you're gonna worry about 0.04 CFS. How does this design flow compare with the sum of the design flows for all 3 inlets? It's also less than the sum because of the different peak timing, right? So if we add it all together, we'd have almost 20 CFS, and you might have to go into a 24-inch pipe or a 30-inch pipe. I think a 24-inch pipe can handle about 10 CFS, concrete pipe. So you might be into a 24 or even a 30-inch pipe, and you don't have to be. So think about that. And that also affects the cover you have to have on top of that pipe. Now you have a higher depth, you know, of the pipe. So you can't get the 2 feet of cover, you gotta go down more. That means more digging, excavation, all that stuff. You don't wanna do it. So be careful with what your calculations are doing. When a storm with a duration equal to the time of concentration occurs, what % of the watershed is contributing as the storm ends? Nick says 100%. What's everybody think? Does everybody agree it's 100%? You got any other ideas? You all look like deer in the headlights. 100%? I hear another 100%. Yes, Nick. Yeah, it's 100%. That was one of the assumptions of the rational method. When a storm with a duration equal to the time of concentration occurs, you get the maximum peak flow. Okay, so I have one other question for you. It's not in your book. And I'm not the best artist. So let me ask you this. This is your Haida graph, your rainfall intensity. And it is the same all the way across to time to peak. So at the time to peak, intensity has been the same the whole time. And so you can come up here and find your peak flow. So let me ask you this. If it continued to rain, would the peak, would the discharge, should have done this, sorry. Forget that. Would it stay the same? Would it increase or would it decrease as the rain continued?
Same. Go down.
It would go down. Someone's saying down. What do other people say?
Based on extremely,
Remember the assumptions of the rational method.
assuming that we assume B, it's not necessarily realistic.
Okay, you're saying B, it'll stay the same. The peak will be the peak. Anybody else?
So it's going down.
You say it's going down? So 2 for down, 1 for it stays the same. Anybody else? You saying the same? How many say it's gonna go down? Okay, we have a few. How many say it's gonna stay the same? A few more. And how many say it's going up? Okay, remember the assumption in the rational method. We said that the peak occurs when the entire watershed is contributing. That's the time to peak. So if you have the same rainfall intensity at the time to peak. It's your peak discharge. So even, and right at that peak discharge, the entire watershed is contributing with the same amount of rainfall intensity. So it's going to be the same. It will just continue because you have the same amount of rainfall coming. It's just steady. Only an inch an hour. It's just steady. So your peak for that is your discharge peak. And it doesn't matter if it keeps raining at that 1 inch because that it's just going to keep sending out the same amount of discharge because the entire watershed is already contributing. Right? Understand? It can't go down because your rainfall is still happening at that same intensity. Make sense?
But it doesn't go up because the entire area is already contributing.
Exactly. It's the same intensity and the whole drainage area is contributing.
Think of it like a bathtub that the drain is releasing the same amount of water though that is coming in. If there's more water coming in, then it's going to fill up and it's going to keep going. Or if there's less water, it's going to come down.
Yeah.
Then what's going out the drain.
Okay? So let's go over those learning objectives again. We identified flow paths for estimating times of concentration. We segmented a flow path into appropriate components, and what were those? For the national rational method, there were 3 components. What was it?
Sheet flow?
Yes. You said something.
Overland flow.
Overland flow,
Shallow concentration.
shallow concentrated flow, channel and pipe flow. And then for the Missouri method, it's what? Yeah, but the segments are overland flow and.
And the curvage, essentially.
Okay. Yeah, so, good. So we estimated peak flows from a single drainage area using MoDOT's rational method, and that was Inlet A. Actually, we did it for that composite area in the workshop. And we adjusted the time of concentration and peak flow computation for storm drainages. I know we didn't do that. Did we? Kind of, yeah, we did that. That was in the workshop. So, any questions about the rational method? Okay. So